This is my application experience research. My topic is talk about teachers' knowledge and belief of teaching word problem solving in elementary school. The rationale for this research question is that, first of all, word problem plays a significant role to help students develop their initial competence in using mathematical knowledge. Secondly, word problem becomes an important focus of instruction in early elementary grades. Thirdly, unfortunately, U.S. students continue to struggle solve word problems. Also, a lot of researchers suggest that teachers' beliefs and values about the nature of mathematics and mathematics teaching and learning affect their teaching practice. In research field, some new strategies and theories explored how to solve word problem and teachers' belief. However, it is not clear whether teachers use these new strategies or theories in their classroom. Therefore, this study will focus on the questions: how does elementary teachers teach word problem solving in the classroom? How teachers' belief influence their teaching practice. This study used two theoretical frameworks to capture and analyze teachers' teaching in solving word problem. The first theory is from Davenport. According to Davenport, knowledge for teaching is divided into content knowledge and pedagogical content knowledge. This study used this frame to analyze teachers' instruction in solving word problem. Another theoretical framework is about teachers' belief. It is proposed by Simpson and Prevost. They divided into teachers' belief into traditional and inquiry orientations. Literatures from two fields. The first one from word problem solving instruction, and another literatures about mathematics teachers' belief and their teaching practice. There are three research questions in this study. Question 1. What characteristics of content knowledge do teachers display in word problem instruction? Question 2. What characteristics of pedagogical knowledge do teachers display in word problem instruction? Question 3. Is there some difference in mathematics teachers' belief? Does the different belief of teachers' mathematics influence teachers' teaching practice? Methodology. Participants. Two participants from one elementary school. They are in-service teachers. One is from the first grade, another is from the third grade. Their age is from 13.6 to 45. There are two females. One is a Hispanic and one is an Asian background. This study conducted in Lubbock ISD District, U.S. This study focused on addition and subtraction word problem solving and fraction. This study used questionnaire, interview, observation, and group interview as instruments. Procedure. The first step to letters seeking approval at school district administration and school administration. The second step to mathematics teachers recruited in this study. Thirdly, teachers were surveyed, interviewed, and observed in a 30 to 60 minutes lesson, and then 3 students in this class were interviewed for getting feedback about this lesson. The data from interview of teachers and students, teachers' belief questionnaire, and a video recorded lesson. To understand the teachers' opinions about
Today
the word
we will
problem
talk about
solving
the word
and
problem
their
solving.
beliefs,
Could you tell
I
me about
interviewed
word problem
the
solving in your
teachers.
teaching experience?
I've actually done word problems since I've started teaching because
Yeah.
here at Ramirez most of the year, all 9 years except for one, we've been self-contained,
Yeah.
meaning that we teach all subject areas.
Mm.
And so that 1 year that we were not self-contained, I was the math teacher for third grade.
Yeah.
So all 9 years, I've had experience with word problems and problem solving in math.
In math, okay. Do you think it is very difficult to teach?
Yes, it is, because especially as the years go on, I don't know, it's like the state of Texas or just the United States in general. I want to try to complicate the word problems to make it more difficult for the students to kind of decode and know the meanings of the word. Plus, a lot of the vocabulary that is used in problem solving, some students have not been exposed to that kind of vocabulary. So therefore, it makes it harder for them to figure out and how to solve. Yes.
Do you think the vocabulary is very difficult to understand?
Yes, because it's not common vocabulary that you would use.
Not common vocabulary.
It's not common vocabulary that students are exposed to every day in just everyday interactions. So that kind of complicates it, because then we have to front load the vocabularies, meaning that we have to teach the vocabulary before we can go into the problem solving the strategies and work on solving the problem. When do we
to know how they're teaching word problems in the classroom, I observed the class and videotaped it.
Plus, you're going to get a little introduction to regrouping, which I know we did a little bit of it, but we're really going to practice it during this time now. So, let's look. Everybody needs to be looking at A. Do I have somebody who wants to read A to me? All right, now let's read A.
Harry had 75 gummy bears. He gave 28 gummy bears to his grandmother. How many gummy bears does Harry have now?
All right, if you remember, when we are looking at a word problem, the answer is the last thing we want. So I have people reaching for their base 10 blocks, and I don't know why. The answer is the last thing that we want. We want to make sure that we understand this problem. So what, in your own words, remember, in your own words, what is this question asking? Miley.
The question is asking how many gummy bears does Harry have now.
Okay, did you read it word for word? Did you say the question word for word? Could you just be like, we need to know how many gummy bears Harry has? Yeah? Okay. So yes, we need to know how many gummy bears he has. What information do we know already? Tell me something that we already know, Gavin.
Harry gave 75 gummy bears to his grandmother.
Okay, but is there information that we knew before he gave it away? What do we know before he gave it away, Skyly? What do we know before he gave it away?
He had 75.
All right. So first thing first, we're gonna add. I see how. Okay, now let me hold the marker, so I know with it being in there, it's gonna be. This. So let's try. First, let's underline our question. Which mine underline is going all crazy. So underline your question, because that's what we're looking to solve.
How many gummy bears?
We want to know, now that he gave his gummy bears away, how many he has. And then as Skyly told us, we know that Harry started out with 75. Ooh, look at that. We know that Harry started out with 75, so we're going to circle 75. And what did he have 75 of?
Gummy bears.
So we're going to circle gummy bears. All right, and then Gavin told us that he gave his, what a nice friend, because if I had some gummy bears, I wouldn't be giving no gummy bears away. But what a nice person Harry is, and it says that he gave his grandma 28. So we circle 28 and we circle gummy bears. question is asking how many does he have now? We know that there is some information that we have to solve the problem. We need to decide what operation are we going to do to solve this problem. Are we looking for a whole or are we looking for a missing part? What operation are we going to do to solve this problem? Nasifa? We're looking for the whole? Did it tell us how?
Findings. For the first research question, I found in the common content knowledge field, two participants had solid content knowledge and tried to present basic content knowledge to students. For example, they can pronounce the terms by mathematic words. They were able to recognize errors about these concepts. For the calculating process, two participants pay more attention to how to calculate a right result. Also, they can create appropriate word problems to address certain concepts or terms to kids and how to solve these problems correctly in mathematical strategies. They also showed solid specialized content knowledge in their teaching. In concluding, two participants had solid content knowledge and presented knowledge to students. However, they did not use some new knowledges of word problem solving, like word problem types. Finding 2 is about pedagogical knowledge of teachers. In the knowledge of content and students, I found my participants thought students' ideas about mathematics are very weak, and most students have difficulties on word problem solving. But in the students' interview, students did not think so. Thus, there is some inconsistency between teachers and students. To the students' misconception, two participants realized it, but they did not use student misconception to reinforce correct conception well in their teaching. In the field of interpreting student understanding and student language, two participants have the different traits. In conclusion, although my participants know student ideas and misconceptions in math, but they did not emphasize why students hold these ideas or misconceptions and interpret it carefully. In knowledge of content and teaching field, I found my participants have the strong ability about it. For example, two participants had a strong consciousness to design a good lesson. In the representing field, two participants can represent mathematical knowledges in different ways, but there is some limitations for their representation. For the student deep understanding, participant A and participant B knew that they needed to use examples to reinforce student understanding of content knowledge, but they only use few examples in their teaching. For the research question 3, teachers' beliefs, I found participant A and participant B had a similar belief in the nature of mathematics and teaching mathematics. However, two participants had some difference in belief of learning mathematics. For example, participant A agreed with some people are good at mathematics and some aren't. However, participant B disagreed with this statement. I also found teachers' belief about the nature of mathematics and mathematical learning and teaching have some consistent with their teaching practice. Potential solutions. This study concluded that teachers had solid content and pedagogical knowledge in teaching word problem solving. However, they did not use conceptual knowledge and new teaching strategies in their teaching. They also pay less attention to student ideas and misconceptions. Thus, there is a gap between word problem-solving research and real teaching practice. Potential solution is giving teachers more intervention about new knowledges and methods in word problem instruction. Secondly, teachers' mathematics belief is complex to tied to their teaching practice. In some extent, there is consistency between their beliefs and teaching practice. Future study is to explore how impact teachers' mathematics beliefs and their teaching practice.